Hello? Are we doing it right this time? Hey everybody, Mr. Andy. I'm getting ready to start MAIN-iac Science Labs. Are we going live?
I don't see it yet.
Well, somebody's watching me.
Good.
Who's there? Hello? Are we ready to do some science today? It's going to be fun. I'll try to stop talking silly. You know, Mr. Andy's a silly guy. But we're in the children's department. We're going to start in just a minute. Make sure everything's running appropriately. But I have my handy dandy. I'm doing this all myself, so bear with me. I'm going to move my camera so you can see the desk I'm going to work at. It's cool. Look, there's all my science stuff. Supplies and things, neato stuff. And there's Mr. Alligator. He's going to be looking over my shoulder, making sure I'm doing everything right. So I'm going to go ahead and tilt it up so I can talk to you. Good afternoon, everybody. We got it. Yay, success. Hey, enough of that. So if you want to do the science experiment today, you're going to need a few things. If you don't have them, don't worry about it. You can always watch this later and gather your belongings at that point and follow along at a later time. It's all good. But if you want to participate right now, live and in person, you're going to need some baking soda, some contact lens solution, just plain old ordinary contact lens cleaner, 4 ounces of Elmer's white glue. Other glue may work too. Elmer seems to work the best. They all have their own ingredients. And if you want to make it funny colored, your choice of food coloring. Otherwise, it's going to be white. So there. If you don't know already, we're working with polymers today, and we're going to be making goo. Yes, it's going to be fun. It's going to be cool, and we're going to learn stuff while we're doing it. I will talk you through it, teach you a little bit about polymers and plastics, give you a little history lesson, and then we're going to make it together. So I'll be making it while you're making it, and then we'll have some experiments with it, and we'll have some fun. What do you say? Is it time? Should we go ahead and get going? Yeah, sounds good to me. I'm looking at my fancy watch, which gives me lots of information. So, just so you know, those are the doors to the children's library. So if anybody comes in, say hello to them. All right, here's the table. That's where I'm going to be working. I'm getting my spot. Okay. I'm still too tall. Sorry about that. Is that better? Yes, you can see the top of my head, and the alligator's moving. What is up with that? He's not supposed to be real. Let me know if he keeps moving. So, welcome to MAIN-iac Science Labs. I'm Mr. Andy, Youth Services Librarian at Main Library in St. Augustine, which is in St. Johns County, Florida. For those of you watching around the world, hope you guys are having fun. Hope you're here to have some fun and learn some stuff. Today we're going to talk about polymers. So any good librarian knows that when you're going to do something, you should do some research first and learn about that something. So I found this book, a handy dandy encyclopedia, which is a book filled with information. This is what we used to use when I was a child, before the Google was invented. Yeah, I know, dark times. But we still learned a lot of cool stuff. So today we're working with polymers. And if you don't know what a polymer is, here's the definition. A polymer, which is how you pronounce it, is a large molecule formed by the chemical linking of many smaller molecules into a long chain. The small molecular building units are called monomers. Monomers are joined into chains by a process of repeated linking known as polymerization. Big words, I know. A polymer may consist of thousands of monomers. Some polymers occur naturally. Others are synthetic. The one we're making today is definitely synthetic because we're going to create it. Let's see. A chain molecule has a definite length, but like a piece of string, it can assume a variety of shapes. This combination of molecular length and flexibility gives polymers many useful and unique properties. For example, rubber and numerous other polymers can be stretched to several times their normal length without breaking. Can you do that with a pencil? I don't think so. They don't stretch, do they? The chains simply straighten into more extended shapes. Because of the large size of the molecules, polymers do not dissolve easily. They also have a high viscosity, which is a resistance to flowing. So, they sound pretty cool, huh? A lot of fun? Polymers are molecules that chain themselves together so they can stretch and bend. A solid, like say a chunk of ice, is a solid. Can you stretch a chunk of ice? No. A cup of water. Can you stretch a cup of water? Not really. Can you hold a cup of water in your hand? No, it just kind of splashes everywhere. It goes all over the place. Liquid molecules spread out and break apart. Solid molecules are very tight together. Polymers are chained together so they can move, but they still remain a fairly solid state. There's an alligator moving behind me, isn't there? You don't understand what's going on. You behave. Don't behave. Okay. So, moving on. Can we think of any polymers you might have around your house? Let's say if you have Jell-O. Would Jell-O be a polymer? Yeah. If you put Jell-O on a plate, you shake it around, it's going to wiggle and jiggle and move. Rubber bands. You can take a rubber band, you can stretch it, and it snaps back. Plastic soda bottles are polymers. When they're empty, you can bend them. They make a lot of cracking sounds, but they don't break, do they? Tennis shoes. Very bendy. And gum. Gum is a polymer. A tasty one, admittedly, probably because of all the sugar they add to it. But those are just some examples of homemade polymers. Now, how did we discover these polymers? Specifically, a famous one called silly putty. Do you guys know what silly putty is? Alligator knows what silly putty is. Maybe your parents know what silly putty is. I bet your grandparents know what silly putty is. Silly putty is a polymer, and the polymer we're going to make today is very similar to silly putty. Silly putty was invented a really, really, really long time ago. An engineer named James Wright was working on a synthetic rubber compound in 1943, and he was having a hard time getting it to have the properties he wanted. So he got annoyed, and he took his little ball of goo that he'd invented, and he stuck it on a shelf and forgot about it for a while. But then a salesman for Dow Corning was playing with this ball of goo, and one of his clients looked at it and said, "Oh, that would be a really cool toy. Kids would love to play with that." Believe it or not, they still do. So that was in the 40s. Silly putty became a toy that they sold to children, and it became a really big thing. In 1957, they put silly putty on the Howdy Doody show, and it exploded. Everybody wanted to play with this stuff. I remember when I was a kid, silly putty was a cool thing. It still is, and today we're going to make our own version of it. In fact, silly putty became so popular that it went into space on the Apollo 8 mission. Did you know that? Pretty cool stuff. So we're going to build our own version of silly putty today. And the polymers that we're going to use are going to have covalent bonds within the molecules, but hydrogen bonds between the molecules. So what's going to happen is hydrogen bonds are easily broken. When small amounts of stress are applied, the bonds will flow or stretch as they break. When larger amounts of stress are applied quickly, like when you yank it, it'll rip it right in half. But you can smush it back together and it'll work again. So, should we go ahead and get started and start making our own silly putty? What do you say? I think we should. Let's make sure you have your supplies. If you don't have your supplies, it's not a big deal. You can always come back and watch this video again later. Fast forward through all the learning stuff and get straight to the fun. And then you can do it on your own again and again and again. It's a lot of fun. So what we're going to need, the most important thing you're going to need is your parents' permission. Once you have that, we can get started. You need to wear something you don't mind getting messy, because we're going to make a bit of a mess today. You need a surface that you can easily clean and not damage. Kind of important when doing science, because things can stain, things can get marred. If you do it on your mama's nice wooden dining room table, it might leave a mark that never goes away. So I recommend like a plastic surface or something like that, a vinyl tablecloth, something protective to work on for your workspace. If you have safety glasses, safety first, put them on. It's a good thing, not a bad idea. Also, we're going to need something to mix. I'm going to use a simple little plastic cup like this. You can get one too if you have one. And something to stir with. I'm going to use a little wooden stir stick to get my stirring on. You can use a spoon, a fork, whatever. Just make sure you get permission first. What we're going to start with is glue. Standard size school glue, 4 ounces is what you need. We use Elmer's. It seems to work really well. We have a giant jug, so what I do is I save my 4-ounce jug, and I just keep refilling it as needed. That's how I measure out my 4 ounces. So what you need to do is take your 4 ounces. It's easier if you unscrew the top. It doesn't take nearly as long. And literally just put it in that cup. Get as much of it out of there as you can. All 4 ounces. Now glue moves kind of slow, so this may take some time. But it's worth it. It's a lot of fun. It makes funny noises too while you're at it. So you can gross out your sister or your mom. It's a great way to spend an afternoon if you're home bored. And I don't know, maybe some of you are home bored and you need something to do. This is a lot of fun. So once you get as much of your glue as you can handle out of that jar, try not to smack it everywhere. I'm going to say that's good enough. Made a big mess already. We just got started. Okay, so you have your 4 ounces of glue in your cup. You need 1/2 tablespoon of baking powder, baking soda. Goodness gracious. Baking soda. Ask your mom. She might have some somewhere in the cabinet. You don't need a lot. You need 1/2 tablespoon. You know it's a tablespoon when there's a B in the name. If it's just TSP, too small. You want the bigger one, TBSP, tablespoon, 1/2 of one. So what you do is you fill your tablespoon, and I always like to do it over what I'm working on, because if you spill, well, you just have to guesstimate your measurements at that point. Just go slowly. Sometimes it comes out in chunks like that. Can you see those chunks? Yeah, that's okay. Not a big deal. You probably want to break them up before you put them into your cup first. So I'm just going to use my fingers. Break it up. 1/2 tablespoon of baking soda. Get it in there. And now for the really fun part. Set your spoon aside. We need food coloring. Now remember, with food coloring, a little goes a really long way. So be very careful with this. Maybe ask for some help. I want to make mine orange. I have red, yellow, pink, and blue. What colors do I need to make orange? You guys know? Thinking a little bit of red is a good start. Let's try putting a little bit of red in there. I'll just put one tiny little drop. And I'm going to try some yellow. 1 drop of red. That yellow looks pretty orange to me. I may be getting what I asked for. So then you stir it up. Stir, stir, stir. Putting the color in before you start stirring helps you know if you're doing a good job stirring, because things are going to start changing colors really quickly. Oh my gosh, can you see that? I'll get it closer. Look what happened. There it is. It's kind of a sherbet color. Think that's orange enough? Maybe I'll put a little more red in there. Interesting. So stir it up real good. Make sure your colors are good and mixed. I'm going to put in a tiny bit more red, just to see. It all really depends on the shades of the food coloring you're working with. Stir it up, stir, stir, stir. Now it's looking kind of pink. But it's a really cool color, so I'm going to stick with it. We're just going to go with it. So now, move your stuff out of the way. Now magic happens. I'm going to take my ring off. Put it over there and my watch. Because I don't want to get goop all over this stuff. Take a little sip of water. And now we need the contact solution. Contact lens solution. Now this one takes 1 whole tablespoon of contact lens solution. So you need the even bigger one. Remember, look for the B. TBSP, that's a tablespoon. And then you pop the cap. You pour it into your spoon. Enough. Are you ready? Here comes the magic. Pour it in your bowl and you start mixing. I'm going to come closer so you can see what's happening. Oh wow, it's already getting weird. Can you see that? It's like turning into cottage cheese. That's weird. You know what? It's not supposed to look like that. I wonder if we didn't use enough glue. Oh no. You know what the beautiful thing of science is? Sometimes you get it wrong. And you know what? I'm going to theorize the food coloring did it. So let's try again really quick. It's not supposed to look like cottage cheese. Did yours come out looking like cottage cheese? That's not normal. Let's try again. I just happen to have more glue, so we'll do it quickly this time. So you put in your glue, blah, 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 lots of glue. So be careful with your food coloring. Apparently too much can really mess up the chemical compound. Because this is all mixing and matching and making things happen. And the more weird ingredients you add, the more trouble you can get in. So, I've got that. Got my ½ tablespoon of baking soda. Shake it in. Break it up. Let's try it without the food coloring this time, just in case. Let's get a new stir stick, because that one's icky. Stir it up, mix it up good and good. See, I should have noticed before, I was getting a lot of bubbles in my glue. So I'm wondering if the glue itself was the problem. But this time we know we used Elmer's. So now we're going to add in our 1 tablespoon of saline solution. Oops. And then we'll mix it up. Let's see if this does better. Oh, already, like magic. Can you see that? That's what it's supposed to look like. It's supposed to be like one big wad of goop. Look, it's all sticking together. Ugh. Much better. So apparently the food coloring we used is the wrong kind. So be very careful with the food coloring. I only had a tiny, tiny little amount. I've done it before with food coloring, and it worked, but not this time. So, now that you've got your wad of stuff in your cup, now you can take it out of the cup and put it on the table. Again, make sure it's a table that you're okay with doing this on, so Mama doesn't get mad at me for showing you how to do this, all right? See, look at this. This is really sticky. We don't want it that sticky, so we need to get a little more contact solution in there. Just put it, if it's too sticky, put it back in the cup and splash it around a little bit. Then we're going to put it on the table and start kneading it like it's bread dough, like you're making some bread or some pizza. Just like you're making pizza. Smush it around, get in your fingers, goosh it up really good, and just play with it. Now some of it might stick to your hands a little bit, that's okay. You can always add it back to your cup, get a little more contact lens solution on it, and then it starts to come together in your own ball of goo that you can play with. It's a lot of fun. Now this is a polymer, so first I want you to, once you've got your ball of goo going, roll it around a little bit, get your stuff out of the way. See if you can roll it into a ball. If you're up north somewhere where there's snow, foreign concept to us Floridians, but a lot of you get to play with snow. Pretend you're making a snowball. Perfectly round. Will it bounce? What do you think? Let's try it. It was a little bounce. Gotta throw it a little hard, but it does bounce. Now be careful you're not bouncing it in a puddle of saline solution, because that can make a mess. But it does bounce. It doesn't bounce like a super ball. It's not that kind of polymer, but it's still bouncing. Now, take that ball, put it on the ground, on the table, and just watch it. What's it doing? Can you see it on the camera? It's so white, it doesn't even turn up, does it? It's right there. It's kind of flattening, isn't it? And if you pick it up, you can see one side is perfectly flat. I'll get closer to the camera so you can see. There's your ball. It's squishing down. The bottom of it is flat because what it's doing is it's taking the shape of the surface that you put it on. If you were to put it in a small cup, it would slowly conform to the shape of that cup. But then you can pull it out of the cup and you can hold it in your hand like it's a solid matter, because it's kind of somewhere in between solid and liquid. It has viscoelasticity. That's the word we learned earlier, remember? So now, let's try something else. Let's take your wad of putty, pull on it. We'll go slowly, and it stretches so slowly. So the molecular bonds are rearranging themselves and stretching. Let's see if I can get it to stretch off the camera screen. You think I can do it? Uh-oh, we found a weak link in the chain. It's gonna break. It happens. But can we go slow enough to keep it stretching without breaking? We're almost to the edges. Oh no, it's breaking up here too. I don't think we're gonna make it, but we are gonna make a mess. Watch this. There it goes. Oh darn. So I got little pieces and I got a big piece. Pick them all up, mush them all together. They go right back together like they had before. So if you move them slow enough, they will stretch. If you go quickly, like this, oh, it'll rip. And look, it's like almost a clean rip right down the middle. So quick movements will make it rip. Slow movements will allow it to stretch, and stretch, and stretch, and stretch. So what else can you do with your wad of goo? I was going to have Miss Marshall make some alongside me. And then we were going to have a contest, but I broke my first batch. So I'm just going to play with mine. And if you hold it like this, what do you think is going to happen? The weight of the goo is going to slowly pull it down towards the table, just with the gravity. Do you think we can get it to stretch all the way to the table without breaking? Are you trying this at home? See if you can get yours to stretch all the way to the table. It's like watching paint dry, isn't it? But it's moving. If you blink, it goes down a little bit farther. Ooh, it's getting there. So I did this once with a class, and I had the kids in the class do a contest to see who can get theirs to stretch out the longest. I'm getting a little worried about how skinny that is up top, so I'm going to flip it over and let it continue going. And would you believe I had one kid in my science class got his to stretch 6 feet long. The same amount of goo that I have right here in my hands. Look, it's almost to the table. They got it to stretch 6 feet long. Can you believe that? All right, so we've made it all the way to the tabletop. So now I'm going to take it in the middle, stretch it out. Now we have 2 long pieces. I'm going to stretch out the top a little bit and let the long pieces keep going. Doesn't this just look gross? Like you can swing it, but I would go very slowly. If you go quickly, it might fling off and land on something your mama doesn't want it to land on. So there's so many different things you can do with your goo. Play with it. Make a mustache. It's a big smiley face. If you have a dog that drools a lot, this may look familiar. I hope not, that's horrible. Oh, look, it's getting longer and longer and longer. So if I stretch it out on the table, you probably can't see it very well because it's so white. That's about, I'm going to guess that's about 3 feet long, maybe longer. And if I kept playing with it, it could continue getting longer and longer. So have fun with your goo. Play with it, experiment with it, see what you can do. When you're done stretching it out, smush it all back together into a ball again, and continue having fun. Now I learned, as a parent, I've done this with my children several times, and if you keep the goo in a sealed container, it will stay like this for a long time. If you don't keep it in a sealed container, it will dry and harden. And I share this with you because A, they may want to play with it again tomorrow. If you put it in a cup with a sealed tight lid, you can just open it up tomorrow and they can keep playing with it. But a word to the wise, make sure you take it back from them when they're done. Not to tell stories about my own son, but he played with his in his bedroom and I forgot about it. A couple days later I found it in the carpet and it became one with the carpet, never to come loose again. I've learned my lesson, so play with the goo somewhere safe and make sure you put it away when they're done. Don't let them run around the house and disappear with it because you never know where it's going to end up, and when it dries for good. So that's goo, a polymer. You now know what a polymer is, and you now know how to make your own. Look, you can hardly even tell that I broke it up. So, if you missed out on how to make it, you didn't have your ingredients ready, go home and get your ingredients, put them together, watch the video again, and then you can make your own, and you can do it again tomorrow, and the next day, and the next day. I hope you had some fun. I hope you learned some stuff. Next week, I think we're going to explore crayons. What do you really know about a crayon? Who made them? How long have they been around? What can you do with them? Let's make some crayon art. I think it'll be a lot of fun. So, tune in next Wednesday at 1:30. We'll do some crayon history. We'll do some crayon art. It'll be a lot of fun. Have fun with your goo for the rest of the day. Make a mess. Enjoy it. Stretch. And we'll see you next time. Don't forget, tomorrow morning at 11 o'clock, story time. I'm bringing the band back together. We'll have the banjo, the ukulele, and the bass. We'll sing and dance, read some stories, have a good time. Good to see you, everybody. Stay safe. Stay indoors. See you next time.